Welcome to the DEFCAM. The recent operational requirements along Pakistan's western frontier have served as a stark and definitive proving ground for a transformative asset in the nation's aerial arsenal, the LS-6 precision-guided glide bomb. This system has fundamentally redefined the application of air power in complex, asymmetric conflicts, moving the paradigm decisively from area saturation to surgical strike. Its emergence as a pivotal tool is not accidental, but is the result of a deliberate and technologically sophisticated evolution in military doctrine, one that prioritizes accuracy, standoff capability, and minimal collateral damage as the cornerstones of modern warfare. The LS-6 is not merely a new weapon. It is a system that has recalibrated the very calculus of engagement in challenging terrain. Conceptually, the genius of the LS-6 lies in its modular and adaptive design philosophy. It functions as a strap-on upgrade kit, a force-multiplying apparatus that transmutes existing inventories of unguided, general-purpose bombs into long-range, precision-guided standoff munitions. This approach is both economically strategic and logistically brilliant, allowing for the rapid modernization of aerial strike capability without the prohibitive cost and lead time of developing entirely new weapon systems from scratch. It leverages the potent, yet dumb, kinetic energy of traditional iron bombs and endows them with a cognitive and navigational capability, effectively giving them a brain and wings. The kit itself is an elegant integration of two synergistic modules, the guidance and control unit, which is the system's neurological core, and the aerodynamic gliding assembly, which constitutes its musculoskeletal structure. The guidance module is a masterpiece of modern avionics miniaturization and redundancy, typically segmented into two primary subsystems that operate in a complementary fashion. The foundational element, often housed within a unit that replaces the bomb's conventional tail cone, is a hybrid inertial navigation system coupled with a satellite guidance receiver. The inertial navigation system provides autonomous, jamming-resistant navigation by continuously calculating its position, orientation, and velocity based on internal motion sensors. This is continuously corrected and refined by the satellite guidance, which triangulates its position from global navigation satellite constellations. This inertial navigation system, or GPS fusion, creates a highly robust mid-course guidance system, capable of navigating the munition through a pre-programmed flight path to a specific set of geographic coordinates in all weather conditions. This is the capability that grants the launching aircraft its vital standoff distance, allowing it to remain safely outside the lethal range of numerous ground-based air defense threats. However, the terminal phase of the engagement demands a level of precision beyond what satellite coordinates alone can guarantee, particularly against mobile targets, targets with poor geolocation, or in missions requiring extreme discrimination. This is the domain of the seeker head, mounted at the weapon's nose. The LS-6 offers two primary seeker options, each tailored for specific tactical scenarios. The first is an electro-optical seeker integrated with a highly sophisticated algorithm known as a scene-matching area correlator. For a mission utilizing this mode, a high-resolution reference image of the target area, obtained from satellite or aerial reconnaissance, is digitally stored in the weapon's memory prior to launch. As the bomb enters its terminal phase, the electro-optical seeker activates, capturing a real-time video feed of the ground below. The terrain contour matching system then performs a continuous, rapid correlation between live imagery and the stored reference image. By identifying and matching unique patterns, contours, and contrast ratios, it can discern any navigational drift and generate precise corrective commands to the control fins, steering the weapon with meter-level accuracy to the intended point of impact. This makes it devastatingly effective against fixed infrastructure with distinct visual signatures. The alternative seeker configuration is a semi-active laser homing system. In this mode, the bomb is equipped with a sensor that detects laser energy reflected off a target. A separate source, be it the launch aircraft, a dedicated designator aircraft, or a special forces team on the ground, illuminates the target with a coded laser beam. The seeker head on the bomb simply detects this reflected energy and guides the munition to the source of the laser spot. This method provides exceptional flexibility for engaging targets of opportunity, moving vehicles, or for executing dynamic retargeting after the weapon has been released from the aircraft. The coexistence of these two seeker types within the same weapon family provides unparalleled operational flexibility to mission planners. The physical enabler of the LS-6 revolutionary standoff capability is its gliding wing module. This assembly consists of large, high aspect ratio folding wings and a set of actuated cruciform tail control surfaces, constructed from advanced composite materials to achieve an optimal balance of strength, rigidity, and minimal weight. Upon safe separation from the aircraft, these wings deploy, undergoing a dramatic metamorphosis that converts the bomb from a purely ballistic object into a highly efficient, unpowered glider. The immense lift generated by these airfoils counteracts gravity, drastically reducing the weapon's rate of descent and allowing it to trade altitude for immense forward range. This gliding phase is what fundamentally alters the tactical equation for the pilot and the aircraft. A fighter can release the weapon from a high altitude dozens of kilometers away from the target area, never having to penetrate contested airspace, thereby vastly increasing platform survivability. The cruciform tail surfaces are the executive organs of the guidance system's will. They are not simple fins, but fully actuated control surfaces that receive constant electronic input from the guidance computer. By differentially deflecting these fins, the system can not only steer the bomb left or right, but also adjust its glide slope, execute complex maneuvers to avoid known threats, and approach the target from a pre-selected azimuth to maximize warhead effectiveness or avoid defensive positions. The system is logically scalable, produced in different variants to accommodate standard general-purpose bomb sizes, such as the 250 kg, 500 kg, and 1,000 kg class warheads. This allows planners to match the appropriate kinetic and explosive effect to the target's nature, ensuring that a small, hardened structure can be engaged with the same precision as a larger complex, but with a commensurate level of destructive yield. In the operational context of the recent border tensions, the LS-6 proved its worth incontrovertibly. The unforgiving topography of the region, with its deep ravines and mountainous ridges, provides natural sanctuary for hostile elements. Engaging these targets with traditional munitions would have required low-altitude flight profiles, exposing aircraft to significant risk from man-portable air defense systems and anti-aircraft artillery. The LS-6 eliminated this vulnerability. It allowed our Air Force to project precise firepower from a safe standoff distance, systematically dismantling terrorist infrastructure, command centers, and supply depots with a level of discrimination that was previously unimaginable. This precision is a force protector, a pilot saver, and a tool of strategic communication, demonstrating a commitment to minimizing unintended casualties and upholding the highest standards of military conduct in the most demanding of environments. The LS-6 is, therefore, far more than a hero of a single conflict. It is the embodiment of a mature, technologically advanced, and principled military capability, ensuring that Pakistan's aerial arm can deliver decisive effects with unparalleled precision and tactical wisdom. Thanks, and stay tuned for the upcoming videos.